equations, but today we're going to go further about quadratic functions, okay? So we remember that from the last time we talked about this kind of things, right? Without equals 0, we have an expression. This is a quadratic expression. When we have equals something, this is a quadratic equation. Okay? When I delete this and say y equals this, we're going to have quadratic function. So 3 things, basically. We started with this. Then we said we have an equation. So this is an expression, okay? Expression. This is a quadratic. The first one is a quadratic trinomial or expression. This one is a quadratic equation, okay? Today we will be discussing y equals ax squared plus bx plus c. This is a quadratic function. And we will be discussing another thing, which is x equals, but the other one is not function, but we'll see later. Okay, so y equals is a function. So let's start solving these problems, okay? Graph the equation y equals x squared by first plotting several points that satisfy the equation to figure out what the graph looks like. Okay, we have this guy, y equals x squared. So first of all, I'm going to show you how to plot points, pick points, and create ordered pairs. Then we are going to graph the function itself. How does it look like using the Geogebra? Okay. So first of all, we're gonna create we're gonna pick points, okay, for x and get the corresponding point, the corresponding y point. So we are going to pick some values for x. Then we are going to plug these values here to get the y value. What values can I pick for x? You can pick any values. More values, more accuracy, okay? At least you need to pick at least 3, 4, 5, it depends. Now, because we don't know how the graph of this function is going to be, so it's a good idea to have so many points. And it's a good idea to have negative and positive points, okay? Just we need to pick from our, from our mind. So I'm going to pick, usually we are picking the negative and positive. So I'm going to take -3, -2, -1, 0, 1, 2, 3. After that, we are going to see what is the value of y that corresponds with each of these values. So this is y here. Now, the first value, when x is -3, what is y?
9.
It's 9. If x is -2, what is y? It's 4. If x is -1, what is y? 1, 0, 1, 4, 9. You just follow from here, right? So these are some points are on this function. Because we cannot graph every single point, we have infinitely many points. but we picked some of them. We picked only these guys. Someone's gonna say, why didn't you pick half? 0.1, 0.3. Yeah, you can do this. But for simplicity, we picked these numbers because the domain is everything. I mean, the x values are everything, okay? So every single point of x has a mirror, has a value for, from the y, okay? So let's take these guys and plot them into the thing here, okay? So the points are -3, 9, right? The second one was -2, 4. X and y, ordered pairs, correct? Next, -1, 1. 0, 0. 1, 1. What else? 2, 4. 3, 9. Look at this. If you take any other point, let's do something. Now we need to match between these points, right? To get the graph. So to match this, I'm going just immediately to so this is exactly what we get. This is exactly what we get. So this is the graph of. So this is the graph of y equals x squared. And this kind of a graph has a name. We call it parabola. We call it what? Parabola. And this parabola, if you try to graph so this is, we call it parabola. If you try to graph any quadratic equation or function, you will be getting something close to this guy, parabola. Okay? So the first thing we need to know is the name, which is parabola. The second thing we need to know here is this parabola. It's kind of, there's a mirror. You can split it into 2 equals halves, right? So the mirror is this. I mean, this is the mirror. This line is the mirror. The right half is equal to the left half. And this mirror, to the right half and the left half, if you just bend them down, they're gonna be exactly the same thing, right? So this mirror has a name. And if you notice, what is the equation of this mirror? This mirror is a straight line, vertical line. This has an, this has an equation. This is x equals 0. This line, x equals 0. X equals 0. In every single point on this line, x is equal to 0, okay? In every single point on this line. That's why the equation of this line is x equals to 0. Does it make sense? Because again, if you pick any point on this line, pick any point on this line, the value of x is going to be 0. That's why the equation of this line is x equals to 0. If I tell you graph the line x equals to 1, that means you're going to go to the number 1 here. I don't, okay, hold on. If I ask you to graph, sorry, what is x equals 1, you're going to tell me, hey, this is the one here. And you asking me to write this equation, which is x equals 1. This is x equals 1. This line represents x equals 1, right? It's a vertical line. If I ask you, okay, let's graph x equals -2, you're going to come here and tell me this is -2, and all points here represent x equals -2. So this line represents x equals -2. Does this make sense? Yes? Okay. So let's go back here. So x equals 0 is the mirror, which is a straight line, the mirror of this parabola. And this mirror, we call it axis of symmetry, axis of symmetry. So this guy, we call it axis of symmetry. Why symmetry? Because the right side of this parabola is symmetrical to the left side of the parabola. These are symmetrical, right? That's why you call this axis, this line, axis of symmetry. Axis of symmetry. Okay. So the axis of symmetry, if you look at the axis of symmetry and the parabola, they have an intersection point, which is this point, right? This is the point where they both intersect, right? This is the vertex of the parabola. Vertex. And this point, they intersect at this point. In this case now, in this example, this point is 0, 0, right? The value of x is 0. Because the parabola opens up, this point is the lowest point in the parabola. So there are many ideas here. Okay, does it make sense? Okay, great. So this is our first question. We need to know these names: parabola, axis of symmetry, vertex, and what is the axis of symmetry? What is the vertex? Now we will be discovering more ideas and how to get these, pieces from the graph. Let's go back here. So to answer these questions, what the graph looked like, parabola, we answered this. Is the graph symmetric? Yes. Is one half of the graph a mirror image of the other half? Yes. Why? We explained why. Because there is one axis of symmetry that, divide these into two halves, right? The parabola into two equal halves. Good. Now graph the equations. We have many equations, and we want to see the effects. Does the coefficient of x squared have on each of the graphs? So we have three different functions. Now, y, the first one we did at the top is y equals x squared. Now we have y equals 5x squared. The second one, we are going to have y equals x squared over 5. And the last one, we're going to have y equals negative x squared over 5. Look, I don't like the idea of writing x squared over 5. Actually, it's a good idea to say this is 1/5 x squared. It's a good practice to have the coefficient times the x squared. The same as here. This is negative 1/5 x squared. Okay, so we prefer these guys, these forms, okay? We will be graphing these three functions. The first one is y equals 5x squared. So the coefficient is 5. If we go back, the coefficient was 1. Now the coefficient is 5. In the second one, the coefficient is 1/5, right? And the last one, the coefficient is negative 1/5. Okay? The graphing in terms of the way that we did it here is the same thing. You just pick points, okay? Pick points for x and find the y values, then plot the points and match them. That's it, okay? But I will not do this. I will go immediately to Geogebra and see the graphs there. Or we can plot the points, then we graph them if you wish. So let's go there here and let's clear this guy. Okay. So the first one, let's see the first one we did. The first one was y equals x squared, right? This is the first guy. Now, let's do the second one. Y equals 5 times x squared. Okay. First of all, our reference is going to be y equals x squared. This is our reference, okay? This is our standard function. This is our parent function. Y equals x squared. And everything else will be compared to this one, the red one, okay? The one in red. Now the one in orange. What is the difference? The one in red and the one in orange. Who can tell me, what can you see? What is the difference? Who can tell me what is the difference between both guys? The one in red and the one in orange.
The one in orange is like more steeper.
It goes up faster.
Yeah, correct. Yes, both answers are correct. It goes faster and it's thinner, right? It's thinner. Okay, the first one, we have y equals x squared. The coefficient was 1. Now the coefficient is 5. 5. When x is 1, y is going to be 5. In the first one, when x was 1, y is 1. When x is 2, y is 4. But for the second equation, when x is 1, y is 5. When x is 2, y is 20. Right? It's thinner, basically, but it's still parabola. Thin parabola. It still opens up. It's still, it's symmetric, right? And the symmetry axis is the same, x equals 0. Do you agree? It's still, we have the same vertex, 0, 0. Let's see the second one. Y equals 1/5 x squared. Oh my gosh. What is this? Fat guy, right? So our standard is y equals 1x squared or x squared, right? When the coefficient is 5, we got something slim or thinner than before. When the coefficient is 1/5, it's fatter than before, but still it's symmetric. Vertex is the same, 0, 0. Axis of symmetry is x equals to 0, right? Okay, let's see the last one. Y equals -5 x squared. So what did we get? It's flipped over. If I just compare these two guys, y equals 1/5 x squared and y equals -1/5 x squared, the first one opens up, the second one opens down. The first one, the lowest value is 0, 0. The second one, the highest value is 0, 0. The highest point. The first one, we got a valley point. For the second one, we've got a summit point. Do you agree? Here we have a valley point. It's the minimum point. 0, 0. But this guy, we've got a point on the summit, the maximum point. We have a maximum point. The 0, 0 represents the highest point, not the lowest point. Do you agree? The reason is why. Because one thing, what is the difference between the coefficient of the first one, of, the previous one and this one? What is the difference? Is the negative, right? Is the negative. So if the coefficient of x squared is negative, the parabola is going to be what? Opens down. If the coefficient is positive, so it's going to be opens up. Make sense? So you go back here. Let me write them here. Let's write what did we found here. So this one is y equals -5 x squared, right? So it opens down. Why? Since, do you remember with this value, we call it a, right? We call it a. Do you agree? Do you remember this? This is my general form. Ax squared plus bx plus c. Someone is going to ask, where are these guys? These guys are not there. These are zeros. Now we have this guy. So since a is negative, less than 0, so opens down because a is negative, right? But this one, all of them, opens up because a is positive. Because a is positive, right? But all of them, we have the same axis of symmetry. Axis of symmetry. Which is what? What is the equation of axis of symmetry? Is x equals 0, right? What is the vertex? The vertex. The vertex is 0, 0. The first 0, look, the first 0 of the vertex refer to this. Because we said the axis of symmetry intersects with the parabola. So this 0 and this 0, are they the same? Axis of symmetry, yes. It intersects with the parabola. So this 0 and this 0, they are the same. So the first 0 represent axis of symmetry. Okay? So let's go back. We explained the effect of the coefficient. So this is, let's say, slim, opens up. This is, let's say, fat or wide, whatever you like to call it, opens up. This is fat, opens down. Right? Our standard, our reference point was number 1. 1 or -1, because if it's -1, it's going to be opens down, but still standard shape, not fat or slim, whatever. Right? So greater than 1 is going to be fatter, or sorry, slimmer than before, thinner than before. If the value is greater than 1. If the value between 1 and 0 is going to be what? Fat. We can try it anyway. Let's clear this. Let's try many of these guys. So our standard guy is this. Let's take what? Okay, the coefficient is 1, right? So let's take something else. Let's take 2. 2 times x. You see that? It's slimmer. Let's take y equals 10. Thinner. Right? Now, let's take something smaller than 1. So y equals, let's say, half. Fat. Let's take 1 over 10. 1 over 10. Let's take 1 over 100. 1 over 100. We are getting smaller values, smaller coefficients, okay? You see that? If the coefficient A becomes very small, we are wider than before, okay? If you apply the negative sign on all of them, we're going to flip all of them. Let's apply the negative sign. Negative. Negative. Oh, what's happening? Oh my God. Negative 2x squared. I don't know why.
I think it's because like the circle isn't filled in.
Oh, thank you. I did not notice that. Apply the negative again. Here we go. Yeah. Ryan says if x equals y squared, it becomes sideways. Yeah, we're gonna see this, correct. It's gonna be opens to right. Thank you, Ryan. Ryan says if we have, okay, what if y, x equals y squared? Yeah, this is no function anymore. But it's gonna be parabola, but it's gonna be opens right or left. It depends on the coefficient of y squared in this case. Yes, we're gonna come to this point. But thanks for pointing this out. Now we are going to discuss another form, because these are the basics, right? So sometimes you're gonna have something more detailed, right? Like x plus 3 squared plus 3. If you remember, we've seen these before. We've seen these before. These are when we completed the square. We used to get something like this, right? Do you remember this? When you completed the square before, we used to have something similar to these questions. So let's graph them and see how and make some connections. Okay, make some connections. So let's first graph the first three. Y plus 3 squared plus 3, y minus 2 squared plus 3, y minus 5 squared plus 3. Let's go there. Y equals x plus 3 squared plus 3. Okay, second one. Y equals x minus 2 squared plus 3. Very nice. Last one. Y equals x minus 5 squared plus 3. Oh, we got something else here. Okay. Let me question. Give me the vertex of each of them. Vertex. Who can give me the vertex of the one in red or orange? The vertex. Who can tell me what this is? The vertex, okay? What is the value of x? Negative 3.
3, negative 3.
Yeah, negative 3, 3, you mean. Correct. What is the vertex of this guy?
2, 3.
2, 3. What is the vertex of this guy?
5, 3.
Perfect. Okay. What is the axis of symmetry? Axis of symmetry, AOS.
Negative.
X, yeah, you should tell me x equals negative 3, okay? It's an equation. X equals negative 3. That means you are telling me all of this. Right? Axis of symmetry is a straight line. It's not just one point. And we said that, oh, there's a connection between this number and this number. What is the axis of symmetry here? X equals 2, because this is the axis of symmetry. What is axis of symmetry here? This is 5, right? And if you look at the value of y coordinate, it's all 3, all of them 3. And the parabola opens up, right? The parabola opens up. And the minimum value is 3 in all of them. 3, 3, 3. The minimum value of the function, which is 3, the y value. When we ask about the minimum and the maximum point, we refer always to the y coordinate. What is the minimum value of the function? So this is 3 in this case, okay? Good. If we go back and compare these values of what we got, let's look at the first function, which is y equals x plus 3 squared plus 3. Who can tell me what is the connection between the equation and the vertex and axis of symmetry?
The number inside the parentheses is the x value.
Okay, then the number in the parentheses, so the first one is x plus 3 squared plus 3. So let me write the equation here just to make it clear for everyone. He's talking about this 3. He can rewrite this to be minus negative 3 squared plus 3. Right? Do you agree? The second function is y equals x minus 2 squared plus 3. Last one is y equals x minus, where is the, y equals x minus 5 squared plus 3. Why did I rewrite the first one? Because look, the axis of symmetry, this, or the vertex, this is the 2 here, and this is the 3 here. Do you agree? The 5 is here, and the 3 is here. The 3 is here, the y coordinate, and the negative 3 is here. So there is a connection between this form, the way that we wrote the quadratic function, and the vertex. So I can give you the function, then I can ask you, hey, give me the vertex. You can immediately give me the vertex of this function. Also, if you give me the vertex, you'll be able to give me the axis of symmetry, because if you know the vertex, that means you know the x coordinate, which represent the axis of symmetry. So so this is it. The vertex, axis of symmetry, the x coordinate, and the y coordinate. Okay, let's do the other bunch of guys. Plus 3 plus 3 plus 3 minus 5. Oh, okay, what do you expect we are going to see? Who can tell me what do you expect that is going to be? These functions, they are going to have what as a vertex?
It's gonna be the y coordinate is gonna be the number that goes after the parentheses on the right, I think. And the x coordinate is gonna be the x plus blank number.
What is the number? What is the vertex of the first one?
3. It's gonna be 3, 3.
Do you agree with him? With
Oh, sorry,
Stas?
-3. -3,
Negative
3.
3. Okay, the second one.
-3, -2.
Last one.
-3, -5.
Okay, so we can imagine where is the vertex now for each of them. So they're going to be not on the same side, basically. Right? But the x value is going to be the same, but the y value is going to be different. So we can see them, the parabolas. They're like underneath each other, right? Here they were beside each other in this case. But now here they're like underneath each other. Let's see. We don't know. Let's see this. So let's okay, let me delete all of them. Y equals x plus 3 squared plus 3. Y equals x plus 3 squared plus, sorry, minus 2, I guess. Yes. Y equals x minus 5 squared minus 5. Y minus 5 here, plus 3. Plus 3. Here we go. As expected. They have the same axis of symmetry. They're, like underneath each other. The same axis of symmetry. The same x coordinate of the vertices. So this is the axis of symmetry. This is the axis of symmetry to all of them. And the vertex is the same. The x coordinate, -3, comma here, 3. -3, comma, -2. -3, comma, -5. Okay. So let's go back. Now, this is the findings. If a quadratic, now we know what did we do, right? We know what is the shape of these equations if we change the values, right? What is inside the parentheses and what is outside the parentheses. First of all, okay, we did not do something, but we did not do this. We did not see the reflection across the x-axis. We did not see something flipped over. We did not see this now. But we can tell that, hey, if A is positive, it's going to be opens up, simply. Right? If A is positive. And what did we find here? We find that H and K, they represent the vertex. H comma K is the vertex. And if A is positive, If A is positive, so it's going to be opens up, right? So H and K, or K is going to be the lowest point. So the smallest point of Y is going to be K, because it's going to be something like this, opens up. This is H, this is K. Why it's going to be K? Because the smallest point of X is going to be H. And H minus H is going to be 0. So Y is going to be K. So it's because since smallest value occurs when X equals H. There's no need to do this, but it's okay. Y equals A times H minus H. I'm plugging H only. The answer is going to be K because this is 0. So this point is a vertex. This is what we need to know. We need to know that the axis of symmetry is H. Again, there's no, you can do this here. Axis of symmetry, we need to know this. Axis of symmetry is X equals H. These are the second, just we need to know these points. And we know the effect of K and H. We have seen them right now. We have seen that K is bringing this guy up and down. Look, the value of K, it pushes the parabola ups and downs, okay? So the value of K is just, we have the minimum value or the maximum value of the function. It depends on this, the K value. Changing X is moving right and left, H. H has a movement of the function, parabola, right and left, right? Okay, questions? Is it clear what we are doing or no? I don't see that, people. Is it clear?
Yes.
Can I take a note for like a second?
Yes, sure.
Okay, I'm done.
Okay. Again, as we said, if A is negative, things will be flipped over. If we just change these guys, if we just clear this before we move on. Let's take, for example, let's say Y equals, let's say we have negative 2 times X minus 3 squared plus 5. The vertex did not change. The vertex is still a 3, 5, as we said, as we investigated already. The vertex is a 3 and 5. Axis of symmetry is still, okay, so this is Y equals negative 2X minus 3 squared plus 5. So the vertex is still, as we said, is still 3, 5. Axis of symmetry is still X equals 3. This is it. And what we need to know that this parabola opens down because of the negative, opens down. What else? This value, the 5, y equals 5, y equals 5, is the max point. I don't like point. Is the max value of the function. Is the maximum. The function do not go beyond this one. It's exactly the same as when you throw a ball. When you throw a ball, it goes up, up, then it reaches to a maximum point, then it goes down. This is exactly something like this. So the maximum point happens here. This is the max. Before it was the minimum point. When it opens down, the minimum points. Okay. Okay. This is kind of a summary of what we maybe did. So let's just read them quickly. The graph of this guy, these are constant. A cannot be 0 because if it's 0, we don't have a quadratic. It's a parabola, sorry. It's parabola with this vertex. Axis of symmetry is this. This is one of the forms of writing a quadratic function. We call it, this form is the standard form of the quadratic function. So this is the standard form, because we will have another form now. And because it's difficult to deal with it, we will try to manipulate and make it as a standard form, because we can deal with this. When we have a standard form, it's easy for us to graph. If I go back, you can immediately tell me, hey, can you graph this? You'll tell me, yes, I can. Why? Because you look at this form, you tell me, hey, the vertex is this, so we can go there. And this one is positive, so it opens up. This is the vertex, negative 3, 3, opens up, so it's going to be something like this. Correct. The second one, you look at this, you tell me the vertex is negative 3, negative 2. So it's negative 3, negative 2, and because it's positive here, so it's, it opens up, so negative 3, negative 2 is going to be something like this. Correct. The same thing here. The vertex is negative 3, negative 5 is going to be something like this. Opens up because this is positive. It's not wide, it's not slim, because the number here is just 1 here. Right? So you can immediately think about the parabola. The same thing as here. If I give you a function, you can immediately give me what's happening. If I tell you, hey, graph this, you'll tell me this is equal vertex A opens down. Then you go there, you look at negative 2, negative 5 here, opens down. Something like this. Right? Let's go back. Let's continue. If A bigger than 0, it's open upward. If A is less than 0, opens downward. If A is 0, we don't have parabola. Okay. The value of A determines how wide the parabola is. The larger the magnitude of A, the narrower the parabola is. Right? This is exactly what we've seen already. Very good. Now, we don't have the form we dream to have. We have this guy. Let me use the split. Okay. So we do have this guy now. Y equals x squared minus 7x plus 6. First of all, it's not a good idea to graph it now. It's not a good idea to make table and graph it because we need to make a sketch. Making a sketch is easier when we have this written in as a standard form. So we don't like this. So we need to think about how we do this. So we need to convert from this form to this form. And we know how to do this because we did it already before. We did this before, how to convert from this format to another format. Using completing the square. We will be completing the square, the method that we used to do, right? Okay, y equals x squared plus 7x. Before, let me tell you something. Before, if you remember, we used to have an equation. We said that time, if you remember, we said, hey, we don't like this C, we're gonna create our own C. So what did we do? We throw this there. Do you remember this? We throw the C to the other side to create our own C. But now, what we are going to do, there's no right-hand side and left-hand side. We have only one side now. The right-hand side, we will not do something in the left-hand side because we're gonna keep it y equals, okay? So what we are gonna do, we're gonna just do something simple. We're gonna just make the 6 away a bit, that's it. That means we're gonna exclude the 6. I mean, just leave the 6 alone. Okay? And if you remember, what we used to do, we used to add, right? We used to look at this number, divide by 2 and square it. So we used to have 7/2 squared. So we're going to have positive this what we did before. This is exactly what we did to complete the square. We used to look at this guy, right? We used to divide it by 2, then square it. Because this is the C, if you remember. This was the C, the relation between C and A. Go back to our previous lessons, okay? We took this guy, -7. Divide by 2, then square it. So this is my own C. This is our new C. Yeah, but the problem that you can't add only. You can't add to a function a new value. So what we need to do is, okay, we're gonna add our C, but at the same time, we are going to subtract it. So in this case, we guarantee that we did nothing, right? We are not playing with the, I mean, we don't do anything. We are adding something and we are subtracting the same thing to the equation. So nobody gets hurt. Nobody gets hurt. We did not change anything. We did not do anything. We just added 0, nothing. Do you agree? But we are manipulating. We need this addition value because my goal is to gather these together. These guys, we love them to be together. These 3 guys, because we know this is a perfect square. This is a perfect square. Then what happens to the last 2 guys? Yeah, we add them, no problem. So add this -49/4 plus 6. So just add the fractions, we're gonna get -25/4. Make sense? So what did we do? We just moved from one form to another form. That's it. So now we do have this. Who can tell me what are the values of A, H, and K? Before we do this, let me write something. So what did we do? Again, we had this. Then we rewrite this. We rewrite it into standard form. By completing the square. So basically, y equals x squared minus 7x plus 6. This is equivalent to this. These are equal, guys. I'm using 3 equivalent, okay? So this is the same as this, okay? But different formats. But we care more about this form. This is helpful. Now, based on this, who can tell me what is A, what is H, what is K?
A is 1.
Okay.
H is 7/2.
H is 7/2.
And
K.
K is negative
K is
25/4.
24/4. No, 25.
Thank you. Who can tell me what is the vertex?
The vertex is
7
over
halves comma negative 25/4.
What is the axis of symmetry? X equals
7/2.
what? 7/2. So the parabola opens up or down? Is it open up or down?
it opens up.
Opens up because A is positive. So now we can imagine, now we can graph, sketch. It's not necessarily to be accurate graph, you know, it's gonna be kind of a sketch, that's fine. But at least you can figure out which point you're gonna pick if you wanna graph it 100%. For example, now we can say, hey, this is the parabola. So the vertex is 3.5, right? Something here. And let's say about -6 here. And it opens up. This is the sketch. But the good point is what? if you'd like to pick point for x, it's a good idea that you create a table. Look, to be accurate, you know which point you're gonna pick. You can tell me, okay, because the symmetry is here, and this is 3.5. Then the values of x you're gonna pick like 5, 4. Then you're gonna go 3, 2. That's it. If you would like to do so, you take 2 points here, 2 points here to just exactly match the graph, right? Okay. Another problem, and let's do this together again. Again, we are not happy having this because this format is not helpful. So the first idea is to complete the square. To complete the square, we need to create our own C. That means we don't like this C. The second thing, when we had the equation before, we used to divide by A, if you remember. We used to divide everything by A, by -3, because we need to have 1 as a coefficient of x squared. Do you remember this? But now we cannot divide because we don't have an equation, we have a function. So we're going to use something similar to the division, which is factoring out. So what I'm going to do, one student is going to say, well, how do you factor out? What about this? No, this is not out of the game. Our goal is to complete the square here. So I'm going to factor out the -3 from here. So I'm going to factor out the -3 from here only. Okay. Then we are going to complete the square here, actually. So how to complete the square? We're going to look at this number, which is 4. We divide by 2, then we square it, which is 4. So I'm going to add 4 and subtract 4. How did we do this? We looked at b over 2 squared, which is 4 over 2 squared, which is 4. Again, we explained this earlier before. Now we are completing the square, but there's something bothering us. Again, look, I added 4 and subtracted 4. That means I did nothing. Someone's gonna ask me, why didn't you subtract 4 outside the parentheses? No, you cannot do this because you added 4 inside the parentheses. So you're gonna subtract 4 inside the parentheses because we have something factored out. It's gonna affect the game. Okay, so that's why we added, subtracted in the same place. Now, the lovely thing is what? Okay, the first 3 guys, we care about them, but we don't care about the last guy, the -4. So we're gonna throw them out. So we're gonna take him, we're gonna give him the -3. We're gonna multiply the -3. So we're gonna keep this, the -3 outside for these guys. But hey, take your share of the -3. I'm gonna give you the -3. I just distributed the -3 between 2 groups. The first group stays the -3 outside. The second group, which is the -4, we give it, the -3. That's it. Because we're gonna get rid of the -4 out of the parentheses. Do you understand? So the -3 is multiplied already by this guy here, because I need this guy to be out of the game. Now I have a perfect square. These guys together, so y equals -3 and these guys together. -4 times -3 is +12, minus 5 is +7. So what is AB? What is AHK? AHK. What is the vertex? Right? So -2, +7, -2, -2, +7, something here. This is -2, this is 7. Opens down. This number is a 3. 3. 3 means going to be narrow, kind of narrow. Something, I don't know. Okay. Maybe no, narrower than this. Question. Is it clear? Okay. So let's go back here. Standard form of the parabola with a vertical axis of symmetry is this. And the vertex of the graph is HK. I did not mention this. There's no need, just because you have seen it already. Just take care of the negative format, okay? For example, this, when you see this, did we make a mistake here? No. Yeah, I mean, it's a good idea to rewrite it like this. H, okay. It's -2, 7, not. It's a common mistake, to be honest. That's why maybe here we have a warning that students mix up this. They think that's 2, 7. No, just take care of this. It's negative 2, 7. Okay, now we have something else. Something funny and something similar to what Ryan mentioned. In this problem, we graph this equation. X equals y squared over 2 plus 3y plus 1. Let's complete the square on the right-hand side. Okay, so let's do the let's complete the square here. X equals, remember, this is x equals, okay? X equals y squared over 2, 3y plus 1. Now, I'm going to complete the square. So the first step is take this guy away, right? And we are going to pull, again, I told you, don't write it like this, okay? Then we're gonna pull the half out because we need to have the coefficient has to be 1 for the y squared. So I'm going to pull half. I don't care pulling the half from here. Just we're gonna pull it from the first two terms, okay? So pull half out. When you pull the half of the 3, you're gonna get 6y plus 1. Okay? Let me make space for myself. Now, x equals half y squared plus 6y. So what number are we going to add and subtract inside? It's going to be positive 9, negative 9. Why? Because 6 over 2 squared. This is the 6. Why we add subtract? Because that means we did nothing. We added 0. Now, this parentheses, we don't like to include the last guy, negative 9, is bothering us. So we're going to get rid of him. How? We're going to just multiply him by the half and let him go. Let him take his share of the half. So x equals half y squared plus 6y plus 9. Give him now his share of the half. Now what's happening inside is done because this is y plus 3 squared and negative 9 over 2 plus 1. So we got negative 7 over 2, I guess. You agree? Negative 7 over 2. So what do we have? Who can tell me now? What is A? Question says about, okay. Now we need to think about something about H and K, okay? H and K now, or K and H. Before we do this, before we get any, let's say, guessing, let's take the function and the graph it, okay? Let's take it and the graph it. So it's half, try to remember this, okay? Half y plus 3, negative 7 over 2. X equals, we got half times y minus or plus 3, I guess, minus 7 over 2. Okay. hold on, squared. Okay. Here we go. Who can tell me what? Okay, first of all, this parabola opens where? We copy the equation. X equals half y plus 3 squared minus 7 over 2. This what we got when we completed the square. So now it's clear that this opens right. It opens right. It's not up or down. Because simply the equation is x equals, not y equals. Right? It's x equals, not y equals. So that's why it opens right or left. Opens right, what is your guess? Why it opens right, not left?
Because A is positive.
Thank you very much, Davey. Because A is positive. Let's look at the what? The vertex. The value of y is -3. The value of x is -7 over 2. So what did we get? If you close your eye, and you immediately told me, oh, what we did is -3, -7 over 2, this because you think about y equals, but this is x equals. Look at the difference if you close your eye. It's just the opposite. It's just the opposite. This was h, this what he, sorry, before or here it was h and k, but in this case, no. If we compare them, if we compare these guys, this is -3 here, and this is -7 over 2 here. So this is h, this is k. So the vertex is k comma h, k comma h. And you can still think about this as we did before. You can tell me this y minus -3 minus 7 over 2. Then you can tell me, hey, this is h. This is, I mean, before, and this is k. But the order is different now. K comma h, the vertex, not h comma k. K comma h. I mean, nothing has changed. What has changed is only one thing, the order of the order pairs. It was before hk, now it's going to be kh. So let's go back. Kh, you see that? It's kh. Just the order. Just the order of the vertex. What is the axis of symmetry? Y equals -3. Y equals -3. This is the axis of symmetry, which is y equals h or k in this case. Okay? Just change the, what do you call it, the order, okay? Yes. So nothing is here. What else I'm going to say about this? Yeah, you know, just this is what I wanted to say here. I think I wanted something. Yeah, don't mix up. I mean, the idea is you need to know what is inside here. This is going to be the y coordinate. This is going to be the x coordinate. The y coordinate, then the x coordinate. I mean, basically, I don't like calling them h and k because they're kind of confusing. It's good for you to understand the first one, in this case, is going to be the y coordinate. The second one is going to be the x coordinate. That's it. So -3 is the y coordinate of the vertex. This is the x coordinate of the vertex. X coordinate of the vertex. And -3 is y